Hello, today we are doing 5.5b, which is writing equations of parallel and perpendicular lines. We did the same thing the other day. We're doing 2 days of this because it's very important, because it does show up on your MCA, as well as it is a review of 5.1 to 5.4 as well, because we are still writing equations in multiple forms. So a quick review of parallel lines. Parallel lines are lines in the same plane that have the same slope. If that's true, then they are parallel. So parallel lines have the same slope. It doesn't matter which one you say first. If you say they're parallel, they must have the same slope. If they're parallel, same slope, they're parallel, back and forth, same thing. And this means parallel lines. Same thing with perpendicular lines. If two non-vertical lines in the same plane have slopes that are negative reciprocals, or we call those opposite reciprocals, meaning one is negative and one is positive. And reciprocals, reciprocal means we are flipping our fraction. Then the lines are perpendicular. So if their slopes are opposite reciprocals, they must be perpendicular lines. Or if someone tells you these are perpendicular lines, then their slopes must be opposite reciprocals or negative reciprocals. So let's take a look at our first problem. It says write an equation of the line that passes through the given point and is parallel to the given line. And a reminder that parallel lines have the same slope. So this equation is not solved for y, so I need to solve it for y first. So it's in the form y equals mx plus b, so that we can identify our m, our slope. So we want to get y all by itself. Since y is on this side already, I'm just going to move the 2 to the other side. So add 2. So we have 2y, and over here I have 4x plus 2 because I can't combine those together. And then last, divide by 2. 4 divided by 2 is 2, so 2x plus 2 over 2, which is 1, is equal to y. So that's in the form y equals mx plus b. So our slope in this equation in front of the x is 2. So there is our slope, and if we're looking at parallel lines, our parallel slope also has to be 2. That way they form the same angle. So I'm going to use point slope form because we have a point and a slope. And this is x and y. This is the new point that my line has to go through, my parallel line. So y minus y1 right here, which is a negative 4, that makes a positive. Our slope is 2. And then x minus x1, which is a negative 3. Again, those two negatives make a positive. Now, our goal is to get the form y equals mx plus b, so we want to get y by itself. So I first need to distribute this. 2 times x is 2x. 2 times 3 multiplying is 6. And then get y all by itself. The opposite of adding 4 is subtracting 4. So we have y equals 2x, and then 6 minus 4 is 2. So this is our new line that is parallel to the original line that they gave us. Let's try the same thing, but instead of parallel, now we're going to look at perpendicular lines. So this first point is x and y, but we're not going to use that yet because we need to figure out what is our perpendicular slope. So in order to find our slope of the first line, we need to solve this for y. So I'm going to subtract the 2x over to the other side. We have 4y. Can't combine them, so write your x's first. And then the opposite of multiplying by 4 is dividing by 4. So we have y equals, well, negative 2 over 4 we can simplify by dividing by 2. That gives us a negative 1 over 4 divided by 2 is 2. Negative 1/2 x. And 12 divided by 4 is 3. So this is the line that they give us. Our slope in this line in front of the x is negative 1/2. But we don't want parallel lines. This time we want a perpendicular line. So instead of negative, our slope has to be a positive. Instead of 1 over 2, it has to be 2 over 1, or just a positive 2. So I'm going to use my point-slope form, because we have a point and a slope. And plug everything in. Y minus y1, which is a negative 1, those make a positive. Our slope is 2. And then x minus x1 over here is 8. So our goal is to get the form y equals mx plus b like the other equation. So let's distribute this. 2 times x is 2x. 2 times negative 8 is going to be a negative 16. And then get y all by itself, subtract 1. Our answer is y equals 2x minus, these are all negatives, 17. So this line and this line, if we were to graph them, would form perpendicular lines, perpendicular angles. So one might be like this and one like this. Those would form nice right angles. Alright, we did one like this the other day. We have 3 lines here. We need to solve for y to determine, are these lines parallel or are they perpendicular? So this first one I need to solve to get y all by itself. So I'm going to add 6x on both sides. So we have 4y equals 6x minus 8. And then divide by 4. Y equals, well, 6 divided by 4 we can simplify if we divide by 2. That would give us 3 over 2. So I just simplified 6 over 4. And 8 divided by 4 is 2. So there's our equation, but our slope in front of the x is 3 over 2. This next one, it's already in the form y equals mx plus b. So our slope in this one is, don't forget that negative, a negative 2 over 3. And then our last line, we also need to solve this one to get y by itself, so I'm going to subtract 2x. So we have 3y, write your x's first, negative 2x, and a minus 15. So divide by 3 to get y all by itself. We have y equals negative 2/3 x minus 15 divided by 3 is 5. So our slope in this equation in front of the x is negative 2 over 3. So which of these are parallel and which are perpendicular? Well, line B and line C right here, they're both slopes of negative 2 over 3. So we have B is parallel to C. They have the same slope. But then our perpendicular slopes are slopes that are of opposite signs, one negative and one positive. And they are reciprocals, meaning they are flipped, 2 over 3 or 3 over 2. So here, this one is 3 over 2. This is 2 over 3. Well, guess what? This one is also 2 over 3. They're both reciprocals of line A. A is positive, B is negative. A is positive, C is negative. So A and B are perpendicular, 3 over 2, 2 over 3, and negative, positive. But line A is also perpendicular to line C, negative, positive, 3 over 2, 2 over 3. So we really have 3 answers, that we would need to write down for this question. Our last problem. I would like you to try this one on your own. We did one like this the other day, and then check to see if your answer is correct. It says write an equation that models line A, first the red line, and we want an equation in the form y equals mx plus b. So there aren't any points on here, but I can find some points that would cross that nice nice points, meaning they cross at a nice whole counting number on our x and y axis here. So this one right here is a nice point, and I'm going to say this one also is a nice point. So I'm going to use those 2 points to find my slope. My slope is rise over run, so I'm rising 1 and running 1, 2, 3. So my slope is 1/3, so y equals 1/3 x. And then plus b. B is where we are crossing the y-axis. It's our y-intercept. And we are crossing at 1, 2, 3, 4, 5, 6. Right here we cross the y-axis. So plus 6. Same thing for line B. We need an equation in the form y equals mx plus b. So our slope of the blue line, I'm going to use the same point, and I'm going to maybe use this point. If you instead want to use this point or this point, you should get the same slope. We're rising or going down 1, 2, 3. We're going down -3 and over 1. So y equals -3 over 1x plus b. This one also crosses the y-axis, this line, and the same spot, which is 6. So it's asking us the question, do these lines form a right angle? We know right angles are perpendicular lines, meaning the slopes are opposite reciprocals. So looking here, our slope is 1/3. Our slope here is -3 over 1. They are opposites, positive, negative, and this one's 1 over 3 and this one's 3 over 1. So yes, because the slopes are opposite reciprocals. That would be our justification. All right, your homework today. We do have an in-class assignment first, and then you do have your assignment, which is 5.5. Almost identical to what we did in class today, and there are 2 problems on the back.